Hi dear friends, in this video we solve this example. This question is asked in the Karnataka State Eligibility Test 2025. Okay, so here we are given a matrix here, that is a 3 cross 3 matrix. So we have to find the minimal polynomial of this matrix. Is it clear? So let us consider this one as A matrix, that is A is equals to this matrix. So let us consider the characteristic polynomial. So characteristic polynomial. So that is given by determinant of a minus lambda I, that is equals to 0. So if you subtract lambda I, what is I is? I means the identity matrix for the 3 cross 3 here. Is it clear, student? So if you subtract lambda into identity matrix of order 3 cross 3 from this A matrix, so you will get this one. So I'll write the directly determinant. So 3 minus lambda, these elements are as it is in the first row. So similarly in the second row, this 2 becomes 2 minus lambda 0. So 1 minus 1 in the third row, this becomes 2 minus lambda. So that is equals to 0 now. So let us evaluate this determinant. So since the third column contains this element also 0, this element also 0, so just simply expand this one by along the third column. So that becomes, this is plus minus plus. So therefore 2 minus lambda into, so how to expand this determinant along the third column? This is already 0, this one is also already 0. So sign convention is plus minus plus. So therefore 2 minus lambda, skip this third column and third row. So we are left with 3 minus lambda into 2 minus lambda. So that is equals to 0. See here students, this lambda minus 2 or 2 minus lambda, that is repeated for 2 times here. Sorry, that is repeated for 2 times. So for minimal polynomial, here we asked to find the minimal polynomial. Minimal polynomial means, so we have to consider the repeated eigenvalue only one time. Sorry, only one time. So that is, so 2 minus lambda 3 minus lambda. So minimal polynomial is, so we have to consider the repeated eigenvalue only one time. Here 2 is the repeated eigenvalue, so that is repeated for 2 times. So consider it only for one time. So 3 also one time. So this is what the minimal polynomial of this given matrix. So this should not be equals to 0. Sorry, this is not equals to 0. To find the eigenvalue, we have to equate this determinant value to 0. So whether if we ask simply to find the minimal polynomial, that is only 2 minus lambda 3 minus lambda. So in this example, so in the options, that is lambda in terms of, that is t. So therefore the option C is correct. Is it clear, students? So let us come to the next question. So this is what the next question is. So in the next question also, this question is from the functional analysis topic. So here we are given two vectors, that is x and y, two vectors, so which are orthogonal. So both of the vectors x and y are orthogonal vectors in the inner product space. So if two vectors are, so let us see the solution. So x and y are orthogonal. So if two vectors are orthogonal to each other, so then that implies that inner product is denoted by this symbol, inner product of x and y, so that should be equals to 0. We know this fact. So that is, if two vectors x and y are orthogonal vectors, so then their inner product must be 0. So then we have to evaluate this value, means we have to compute the value of this norm of x plus y whole square. So let us consider the value of this one. So that is norm of x plus y whole square. So we know that, before going to this one, so we know that what is norm of x whole square is, so this double mod is known as norm of x whole square. So norm of x whole square means inner product of x with x itself. Is it clear, student? So inner product of x with x itself, that is only the norm of x whole square. So here we have norm of x plus y whole square. Consider norm of x plus y whole square, that is equals to, so here replace the x by x plus y. So x plus y comma x plus y. So now, so here also we have two vectors. Second term also we have two vectors. So let us take the inner product of this x with these two vectors. So then y with these two vectors. So what we will get? Inner product of x with x. So x comma x plus b. So we have plus. So then x with y. So inner product of x with y. So then second vector. So that is, second vector is y and first vector is x here. So therefore inner product of y comma x. So lastly inner product of y with y. So inner product of y with y. So we have, so here only we seen that inner product of x with x itself means that is norm of x whole square. So this x inner product of x with x itself becomes norm of x whole square. So here in this inner product space, so they are given that so x and y are orthogonal to each other. So both of them are orthogonal vectors, so that we have inner product of x comma y is 0. So therefore this element becomes 0 and this is also 0, because if so here inner product of x comma y becomes equal to 0 means so inner product of y comma x is also 0. Is it clear? So therefore it is also 0 plus, so what is inner product of y with y itself? So that is norm of y whole square, that is norm of x square plus norm of y whole square. This is what the answer is. So that is option A is the correct one. Is it clear, students? Thank you.